Okay, so we're now recording. So, as I say, welcome back to this next part of the Singularity course. So this morning we looked at some very basic Singularity commands, looking at how to pull images both from Singularity Hub and from Docker Hub, and then we looked at some different commands for running shells, running commands within those containers started from those images, and so on. What we're going to do this afternoon is look at some more advanced topics. So we're going to look at building images, and then we're going to move on to look at running images in parallel on the ARCHER2 platform that we're using for the course. So what we're going to do for building the images, so this morning we worked mainly on the remote platform that you were given access to. For this part of the course, we're going to do a combination of working on your local machine, where you will have the opportunity to build on your Docker skills that you learned yesterday, and then a bit later we'll move back onto the remote platform to look at how we can run images that we've created. So what we've done so far, and as highlighted in this section of the material, you've worked basically from your own user account with Singularity as a non-privileged user. So this was great because we could log into the remote platform, we could use Singularity straight away, we didn't need any special privileges, we could run containers as we saw, we could get a shell in those containers, we could go and look at various files within there. We saw that some of the files were owned by root and we didn't have access to them to change them, but we could read them as necessary to run applications and tools and so on. But what we want to do this afternoon is we want to actually be able to build our own images. And when you want to build your own images, we are going to do this on a platform where we do have root access. So to provide that, we're going to use Docker. Now, there are a number of different ways to build Singularity images. There are options that you can build them without having root access. There are various different pros and cons of these different approaches, but we're using this approach that we're taking in this part of the course as a kind of general approach that seems to work reliably, and it gives you the most flexibility. So Singularity, as I think I highlighted this morning, really needs to run on a Linux platform. It potentially can run on Mac, and I don't know if any of you have tried that. Some of you may have done with some success, but we're focusing on running here on Linux. And of course, you don't all, I'm sure, have Linux machines that you're working on. Some of you will be working on Mac, some of you will be working on Windows. So to provide us with a kind of general platform that we can all work with, we're going to use Docker, and we're going to run a Singularity container within Docker. And that will be our environment within which we're going to actually build our images, which we can then subsequently take and run on other systems. So there's a note here that I highlighted this morning about installing on your local system, and I think some people did actually manage to install on their local system, but that's what we're classing as an advanced task here. It's optional, it's not something that's required to proceed with this part of the course. But equally, if you have tried to do that successfully, then you can indeed continue with this part of the course running on your local system, and you should be able to interact with the material that we cover successfully if you have a working install on your local machine as well. But as I say, we'll use the Docker container here. I'm going to now start to give you some background on the Docker Singularity image and how to pull it and work with it. Again, there are some notes just above here in this section about some other options. So this is really just to give you a bit of background and some different ideas of alternative approaches to work with building Singularity images and different ways that you might provide yourself with platforms to do that. If any of you have tried any of those and you have any questions, then certainly in the break, I'm happy to answer questions, and I'm sure the other helpers will be able to do that too. But really, the focus here will be on this Docker image. So the Singularity Docker image, which is linked here, is not on Docker Hub, but on a different repository called key.io. So if I open a new tab with that page from key.io, so we can see this looks a little bit different to Docker Hub. It's, as I say, it's just another repository that's available to store images. we can see that we're looking at the Singularity image. There's some general information. It tells us here that it's a Dockerized version of Singularity. There's a bunch of other notes and bits and pieces there. The bit that we're particularly interested in is the tag section. So if we look at the tag section here, we can see all of the different images that are available, all the different versions of the images. We can see also that for all the versions here, there's both a standard image and a slim image, and you can see that the slim one makes really quite a substantial difference to the size. So we're going to work with this 3.7 image, and as you can see, 3.7.0 slim is only around 82 megabytes. So we're looking at sort of more than 5 times the size for the non-slim version. So it's much quicker to download the small one. We'll work with that. That should be satisfactory for everything we need to do for this part of the course. So that is the image that we'll be using. And as I'll show you in a minute, when you pull your image, as you hopefully recall from the Docker material yesterday, you can provide your tag. So your image is called Singularity, but you can then provide your tag afterwards to say which version of the specific version of the image you want to download. Okay, so what we're going to do now is actually to that we can run it. So hopefully you've got your Docker environments running from yesterday, or you're on a platform where you have access to Docker. If anybody has any problems with that, then please do post in the chat. The helpers will be happy to assist. But hopefully that's something that you're ready to go with. What I will do is just switch over here to my terminal, and I can show you that. So here I'm on my local machine. So I have my Docker available here. So this is a Mac machine, but hopefully if you're on Windows or Linux, you've also got a similar setup from yesterday that we can work with. So what we're going to do is we're going to pull the image from key.io. So if we go to, in fact, if I go back to this page, I can hopefully just show you the tags. So I'm looking if it actually shows you somewhere the main tag. I think perhaps not. Okay, but I've highlighted that this is the one that we want, the 3.7.0 slim. So what I will do, and in fact, if I look at my images, see that I've actually got it here. So a whole load of images here, and in fact, there is the key.io Singularity image. So I'll put that onto the terminal here, so you can actually see what the name of the image looks like. So what we would do is we would say docker pull key.io/singularity/singularity. So that's the name that you can see across here. It's in the Singularity group, and the image is called Singularity. And we are pulling the one which is version 3.7.0 slim. So if we run that, okay. So what you can see there, what you'll probably have seen is a bunch of layers pulling from the repository. Because I've already got it in my local image repository, we saw that it basically says it's pulling, it's checked, it says it's up to date, there's not been anything changed. So it's just telling me that the image is here and it's available in my local repository. Hopefully you will have been able to also pull that image. And I will just go back. In fact, what I'll do is I'll just drop this into drop the base into the chat, and then you can add on the tag. So let's just put that in there for you so you can see the image name. Okay, so a couple of things to note here. Depending on what platform you're running on, you may need to use the ---- privileged switch here. On the Mac, I'm not having to do that, but I think on Linux you may well have to provide that when we run the container. The reason for that is to do with whether the container needs privileged access to the system for the files that are being read and written and so on. We'll see about that, but as I say, that's not required on this platform, but it may be if you're using an install on Linux. So hopefully you've been able to pull the image. What we'll do is we'll now make a directory. So I've got a directory here called Singularity Data. So if you create a directory in your home directory called Singularity Data, or call it anything else that you want, but that's the name that I'm using for this. And what we're also going to do is we're going to do a bind mount. So as we saw yesterday using the -v switch in Docker, we're going to bind mount this directory, home Singularity Data, into our container that we're starting. And just there's a question in the chat here about the pros and cons of using the slim version. So just a quick note on that. Basically, a lot of platforms now provide a slim or a standard image. Generally, the slim image has things missing from it. Basically, that's why it's much smaller. And it depends in different cases what it is that's not present. I don't think, to be honest, that there's actually a detailed explanation anywhere here of what the difference is between the two. But I mean, I verified that the slim image has the basic stuff in it in Singularity to do what we want. But what generally is the case is that if you're looking at certainly Linux containers, which often have a slim or a standard version, the slim version basically has very, very limited packages installed. So a lot of commands that you're familiar with may not exist, and that may also be the case with this particular slim image. I suspect, but I don't know for sure, that this may well just be based on the slim Debian image. I think it's based on a Debian image, so possibly it's just the slim Linux image, and they've installed Singularity into that. So it's very much dependent on the image that you're using, but generally the slim version has things missing from it, and depending on whether or not you need them depends on whether you can or can't use that. If you're looking, for example, at a Linux install, if you take the slim image of one of the Debian distributions, you'll probably find that pretty much there'll be a very, very basic set of commands and libraries installed, but basically anything else you'll have to install from packages. And so that may be fine for you, but if you want something that's kind of ready-made with all of the stuff installed, then you would pull the standard image. But the benefits, of course, are that it's much smaller in size, it's much quicker to pull, it's much quicker to move around if you want to move it to another platform. And certainly for the purpose of this course, to optimize time and whatever, we'll go with the smaller ones so you don't have to wait for ages to download if you're on a slower connection. So hopefully that answers the question. So there's now a couple of questions here. So some of you may already have been able to run the image if you've been able to pull it successfully. So the questions here are: what's happening when you run the container, and can you run an interactive shell in the container? So I'm going to do that myself. I'm going to run it, and then we'll look at the details for that. So let's say I just try and run the container. Let's see what happens. Okay, so what did I see there? Well, in fact, that just looks like the output from the Singularity command, and indeed it is. So what that tells us is that the entry point, or the command that's being run when this container is run, is basically the Singularity command. So what we then need to do is to add on to that any of the various different Singularity subcommands that we want. So effectively, running this command here is a bit like typing Singularity at your command line if you've got Singularity installed locally. So yeah, so somebody actually, so there's a message there in the chat, which is something I'm actually going to show in a minute, which is a very good point. So when we start to work with this, you'll see that if you have to type this Docker command line every single time you want to run one of the Singularity commands, it gets very messy because the command gets very long. So one of the things you can do is to create an alias from the command Singularity, or in fact any other name you want to use as the alias, to this long Docker command, and I'll show you in a minute how to do that. But there's an example there, so thank you for that in the chat. That's really helpful. So that's just the basic command. We've run that. Okay, nothing's happened. But let's say we want to look at the cache as we did this morning. We looked at cache list. So if we run Singularity cache list, we can see the cache is empty. Now that's not really surprising because we've pulled the slim version of the image. We can assume there's not very much. There's certainly no other images in there, and it's basically an empty container with nothing stored in the cache. Sorry, an empty image with nothing stored in the cache. And if we then pull images, what we'll also find is if we run the Docker container for every time we run the command, the cache will always be empty in the if we run cache list, because the the container image is the image itself is not changed. So I can demonstrate that to you. So if I was to go Docker pull, so let's try actually and do this with as a standard hello world image that we can use. I mean, let's go and pick something small. I guess we can do that. So let's go to the Docker Hub. Just go through here and let's search for, so we can do the search. Let's search for hello world and see what, I'm sure there are many hello world containers. Let's pick one. So there is just a standard hello world container. So in fact, let's just pull that. No, still not. Am I doing something? Maybe I'm doing something wrong.
Sorry, Jeremy, do you need the Docker prefix on that?
Oh, sorry. Am I being completely stupid? Yes, maybe I am. That's probably exactly what the problem is. Thank you. Thank you, Chris. Oh, sorry. Yes. I'm getting very confused here. This is not. I'm getting confused because I'm pulling it as though I'm running Docker, and in fact, I'm pulling a Singularity image. Thank you, Chris. This is part of the problem of running Singularity in a Docker image. It's a little bit confusing. So we've now pulled the Debian Buster image, and if we now look at our cache, what you'll see is the cache is going to still be empty. Right. So I don't know if that makes sense to people, but what's basically happened is we've run a Docker container from our Singularity image. We've told the container, the version of Singularity in the container, to download a Docker image from Docker Hub. It's done that, but then the container is shut down. And when the container shuts down, we lose all of the state that was in the container, and we're back to the blank image again. So this is, I hope this is clear, but if not, then please do ask questions. I can try and provide more detailed explanation. But basically, that's just demonstrating to you that that we're working with a kind of standard image. When we do something inside that image, once the image shuts down, then we lose the context of that image, and we're back to just our sort of initial template again every time we start the command. Alternatively, if we were to run a shell, so let's do. Can I do that? Let's have a look. See whether this will. No, it doesn't. That's Singularity is the shell command. What I can do is I can do a Docker run. I think I have to change the entry point to be bin sh. Right. So did I? Okay. So what happened there is that ran, but in fact, so this again, if you might remember from yesterday's Docker command, it ran, but it then exited straight away. And the reason for that was that I forgot. Sorry, I don't know if you've got somebody asking a question or if it's just some background noise, but if you have a question, then please do let us know. I'm just looking whether I'm maybe missing. No, okay. If you do have a question, then do feel free to call out. But okay, so what happened here is the thing ran, but then it exited straight away because I forgot to tell it that I wanted to create an interactive link with a TTY to connect to type in the terminal. Right, so now it's running. I'm now in my Singularity image. This image I can go to. Well, let's just try and show. So I can run Singularity. I can say, as we saw before, Singularity pull. So if I do this correctly this time, I should be able to pull the hello world image. That's more promising than last time. Okay, so now what we can do is if I run Singularity cache list, you'll see that in fact that there is something in the cache because we are actually in the same container instance as before. So because we're in a running container, at the moment the cache has something in it. So right, sorry, there's a question there about the flags. Let me just move this back up so you can see. So so there's the details. So what I've done is I've basically just used the entry point flag. So if you don't use that, so if you don't use the entry point flag on Docker, then it just runs the standard command, which is to run Singularity. So what we're doing here is overriding the bit which runs Singularity and saying don't run Singularity, instead just run a shell, and then we can run Singularity ourselves once we're inside the shell.
Yesterday when we did this, we provided ensure was the command to run rather than changing the entry points there.
Sorry, Andy, we can't hear you very clearly. I don't know if it's just me, but your audio is very muffled and quite distant.
Is that better?
Ah, that's much better. Yes, yes, yes.
Okay, fine. Sorry, what I was saying was yesterday we used Singularity Run with and specified, for example, bin sh as the program we were running, and that also overrides the entry point. And there are two different ways to achieve the same end. We didn't cover the entry point for.
Oh, sorry. Okay.
No, it's okay. It's not your fault. It's useful to see that there's, as with all Unix, Linux things, there's like many different ways to achieve the same ends.
Yes, indeed. Yes, that's it. Yeah. So okay. So yeah, as Andy says. So apologies if that confused things, but yes, you could put the bin sh at the end of the command. So at the moment, this is all fine. We're in a container. We can run Singularity, whatever platform you're on, whether you're on Docker, Linux, or Mac. Whether you're on Windows, Linux, or Mac, you're running your Docker container, and you hopefully can see that we have Singularity there. We have a bit of a problem at the moment though, because we can't actually get anything back onto our host system. So whatever we do in this container, when we exit it, it gets lost, which isn't great. So that's why we needed to use a bind mount, which was highlighted in the information here, saying that you need to use the -v switch. So what I'm going to do, I'm going to exit out of here. My container shuts down. We're back to our regular terminal, and we've got our command that we ran before. And so what we're going to do, there's a couple of other things we're going to add. We're going to add the --rm, because at the moment, if I look at my list of, if I do a Docker ps, we will see a long list of containers that have, every time I've run this, let's do that and show you. So this is actually Docker container list, I think it's the same thing. So again, it's something where there's lots of, that's all right. So the difference is that there's nothing running, so we don't see it. If I do Docker ps -a, you'll see a long list of all these containers that I've run that have exited, but I haven't got rid of them. If we use the -rm switch, it stops all of these from building up, because it just removes them straight away. So that's just going to get very messy after a while. So that's why I want to add the -rm switch. So Docker ps -a, I think, is the same as Docker container list. Is it -all or -v? I can't remember. There's a, let's see, there is a
-all.
-all, right? Okay, -all, -a, right? So Docker container list -a is the same as Docker ps -a that I did before. So I'm just looking. There's a couple of questions there. Let me just go and address those.
/bin/sh, because sh isn't in the path in the container.
Right. Yes. Yes. Yeah.
Okay.
So one of the reasons why we're using sh instead of bash, and in fact, I think bash is actually in this slim image, but often, I mean, I talked about slim images being quite cut down. Often what you find is that even bash is not in some of the slim images. So you might find the only shell that's there is bin sh rather than the full bin bash.
No, this is my fault because I've confused things. So it looks like when there's an entry point set rather than a command, you can't override it by putting the bin sh at the end of the error saying says that if the Docker file defines entry point rather than cmd.
Oh, sorry.
You can't override it. So it was me confusing it and getting it wrong there rather than.
Right. Okay. If it's CMD, you can, right? But if it's entry point, it will always run that because I think if it's entry point, it adds the stuff at the end onto the end of the entry point command.
Yeah, that's exactly it. I ran into the same problem yesterday when I was trying to do the stuff with sum.py.
Right.
So I've made the same schoolboy error twice in 2 days. So.
No, it's fine. I think it's all useful. It's useful stuff because I think it does highlight these kind of minor sort of things that you find as you start to use the different commands. So yeah. Okay, so let's clear that to give us a clean terminal to work in, and let's just go back up through my history. So we did get as far as running this command and getting a shell in it. That's all fine. I said I'm going to add the --rm. The other thing I need to do is then mount my current directory. So I want to be able to do stuff in my container, and I want it to be able to be saved out into my current directory. So when I exit from the container, the files are still accessible to me on my host system. So I'm going to add a -v, which is to do a bind mount, and I'm going to add pwd, the current directory, and I'm going to put that into, so that's going to be mounted at home Singularity in my container. So what this means, if you recall from yesterday when we looked at this, is once we get into the container, there should be a directory there, home Singularity, and it should be the directory that I'm currently in on my host system. So let's run that. And hopefully, if I go to home Singularity, directory exists, that's a good sign. And if I do an ls, yes, indeed, we can see there's some files there. So I can now do stuff in Singularity in this container. I can build things, I can create any sorts of files that I want in this directory, and when I exit from the container, they will be accessible. So in fact, I hope, if you open this running the image tab here, you will actually see an example of this here. I can see something there has gone a little bit funny with the formatting. That's probably just because I've got the window quite narrow. But basically, these commands here should get you to the point, in fact, this one should get you to the point where you are able to get into your container with your bind mount in place and then run Singularity in the container there. So I hope people have got to that point. I'm kind of taking things reasonably slowly, and I hope I'm explaining things sufficiently clearly as to what's going on, because I appreciate it's a little bit complicated if you're not familiar with, especially if you've only just learnt about Docker as well. So do, as I say, do let us know if we can provide any further explanation. I'll give it just a couple of minutes, and I think I'll just do a quick poll so people can tell us if they've got to that point. And hopefully, if you've got to the point where you're in a shell in your Docker Singularity container, then we're in a good place to carry on. I will just put the right. So there's a question here again about the entry point. So basically, what this is doing when you create a Docker container, and I think we saw yesterday in the Docker file, there's an option that you can put in that file which we called entry point. And what that says is when this container is run, this is the command that you should run when the container is run. And what we're doing is, so this particular container is configured such that that command is Singularity. It says run the Singularity command. We don't want it to do that at the moment because we want to run Singularity ourselves. We want it to just run a shell so that we can go into the shell and then we can interact in the shell as normal. So I can now run the Singularity command in the shell here. And what this means is I'm not having to run the container every time I want to run the Singularity command. So using the -- entry point just gave us a way to override the preset entry point for the container and let us to say, don't run Singularity straight away. We'll do that ourselves, run a shell instead so we can get into a shell. I wonder actually if I just exit from the container for a minute, if I can just show you, I'm getting confused again between, can I do Docker inspect? Can't actually. Let's just do that for the key.io image, and rather than trying to type that and get it wrong, I will take this here. Right, so that's actually the output of Docker inspect, and what we can probably see there, in fact we can indeed see. So this is the entry point that's set. So that's the default entry point. So if you just say Docker run and you give it that container name, this is the command it's running, user local Singularity bin Singularity. And so that it doesn't do that, we put entry point equals bin sh instead, and that just gave us a shell instead. So I hope that makes sense. There's also a question there about RM. So what does RM do? Basically, RM means that when the container stops, so in other words, when you exit from the container, it gets removed from the list of sort of created containers. So I demonstrated that when I did Docker container list -all. You can do -all, or you can do -a. What you see here is a whole bunch of containers that I've created, and then so every time I ran the Docker command, so if I, as an example, let's go back to my previous command. So if I take off the RM here, what you'll see, I remove the RM, and I now run that command. Here's my container, I'm in my container, I can do whatever I want to do. Now I'm going to exit from my container. Okay, the container is shut down. If I now list all, what you'll see is that there's another entry in here at the top, which tells me that 4 seconds ago I created this container and it's exited. So basically, I don't want this huge pile of containers to pile up here. So when I use RM, it basically doesn't. This entry will not appear. Once the container shuts down, that entry gets removed automatically. Otherwise, I have to manually remove it from my list. So I could, for example, remove it. So they get these interesting names that are created. So that's the one I want to remove here. For example, I can go. You might remember from yesterday, Docker RM, the name. So that gives me the name to confirm it. And then if I do a list, it's gone from the list. We're back to the one that was 12 minutes ago. But rather than having to do that for every single one, because I know I don't need to start them again, I can just simply use the RM switch. Somebody asked about the order of the options. Yes, they are mostly irrelevant, but the minus minus options, I believe the ordering doesn't matter. But it is important at the end that you always have the container name at the end, the image name that you're creating the container from, and then any commands that you want to run after that. In this case, because we're using the minus minus entry point for the bin sh, it goes in line with all the other minus minus or all of the other switches. But the ones that don't have any switches on, so like the image name and then any commands that you want to run at the end, they have to go in at the end of the command. If you don't do that, if you try to put different commands are different. I'm not sure if it's like this, but often what happens if you try to put a minus minus switch, for example, after the names of the container name, it will just ignore it because it won't understand where to find it. So so there's a question there about privileged. So there are potentially security issues. So if you try to run on it for a start, if you try to run on a platform where you don't have root access, you can use privileged. I don't think you can, because I think the point is that it's giving it's giving Docker access to some kind of system resources that it wouldn't normally have access to. So generally, if you're running Docker on a local system, which I'm assuming you are because it's probably the version that you installed yesterday, you will be able to run privileged as an option. But if you try to run it, for example, on an HPC, well, you wouldn't find it on an HPC platform because Docker isn't generally installed on those platforms. So in general, privileged won't work if you don't have root access. But in fact, in the case of Docker, it's fairly unlikely that you'll have access to a system where you don't have root access that has Docker on it, if that makes sense. So I guess the general guidelines are don't use it unless you need to, but you'll kind of know if you need to, because if you try to do something that then fails because it hasn't got enough resources or enough permissions to access things, you'll know that the privileged flag is needed. Normally for a container, it will tell you if that's required. So if you look at containers in Docker Hub, normally if they're doing something special where they need some sort of increased permissions on the system, there will be something that tells you that. So yeah, hopefully that answers the question. So okay,
I can clarify a little bit, or I can add a little bit there.
Sure.
Jeremy, just it's not something that'll be used in production, right? I mean, generally, as we're using Docker here in this course, we're using it as ways to enable research software and things we're doing, right? But the most common use of Docker is for running services, a back end, for example, a web server or some sort of app that you might access via your smartphone or something like that in the cloud somewhere, and then using privileged introduces security risk, because somebody accessing your app or your web server, if they can break into the Docker container, then they have much more rights to do other bad stuff on the host itself. Okay, so the privilege thing is generally production Docker containers will not use privileged, okay, to try and close those security holes, but people might use it in development for developing and testing and things like that on a local system. For our case here, it's mostly irrelevant, except that because of the way Singularity works, you need it to make the Docker container work. But it's not a problem for us because we're not running a persistent Singularity build service over the web or something like that that we're giving other people access to.
Okay, thanks, Andy. That's great. I've just put a poll up there just for people to highlight whether they've been able to get to this point where they can run the container. If you can't, then if you could let one of the helpers know, that would be great, because we'll obviously going forward need to use the this container to actually help us build Singularity images. So if people want another couple of minutes to catch up, then I'm happy to wait for another couple of minutes. But otherwise, if people are happy for me to move on, then I will start to move on to the next section. I don't know. We'll just see if we get. So we've got about half the people at the moment saying that they've got to this point. Maybe we'll just give it another couple of minutes. So while people are just getting to that point, what I'll also just do is highlight the point that was made in the chat earlier about having an alias. So so we can see here that there's basically two options for running this image. One is that we start the shell, as we just looked at. So I can run that, I get a shell, and I can go into this shell, I can run Singularity, and I can do whatever I want to do. And the container continues to run until I exit from the shell. So I can run Singularity command multiple times, I can do various different things in there, and then when I'm finished, I can exit. The alternative to that is that if we take off the entry point, and we just use the standard entry point, which is Singularity, and what we find then is that every time we run this container, we run this image, we get a container which just runs Singularity. So we could actually now put all of our Singularity command, all of our Singularity subcommand things, so Singularity build, whatever we want to do, and a whole bunch of things which we'll see in a moment, at the end of this command, and we just run a new container every time we run the command. It does what we tell it to do, and then it quits. And so either option is okay for the purpose of this course. But what was highlighted was if I wanted to run really simple command like Singularity build and then give it a script to build, a definition file to build, that's very easy to write Singularity build and then the name of the file. If you have to write every single time Docker run -it -v, etc., 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 and then your command, the command gets very long and it gets a bit messy and it's a little bit confusing. So what was highlighted before in the chat was what you could do is you can set up an alias. If you're working in Linux or Mac, this should work. It won't probably work on, there are different ways to do this in Windows. It won't work using this approach. But what I could do is I could say alias, I've got to remember which way around to do this, but I think it's Singularity equals. So I think I can do that. Did it work? No, it didn't like it. Oh, hang on, am I in the wrong? I'm used to doing this normally in C shell, but we're in Bash here, so I don't know whether I've got this right or not. Probably not. Let me see.
You need quotes around the. Sorry, Jeremy. You need quotes after the Singularity equals around everything.
Oh, sorry, just around the whole thing, but I can still. It is correct. Is it Singularity equals? It doesn't seem to like the. Oh, I see. Yes, sorry. I see what it's now saying in the error. Yes. Okay, that looks much better. So now I can type Singularity, and it runs. So just to be clear, I don't have Singularity installed on my system. So that is not running a Singularity that's local on my system. What it's running is this command that we put in the alias. So every time I type Singularity, it's just running this command instead, and it's a little bit cleaner than having to write this long command every time. So that's the other option, is you can do that. But if you want to work directly in a shell in the container, that's absolutely fine. So those are the kind of the two options available for this part of the course. I probably will, I guess I'll probably, now I've got this alias, I'll probably just use the command that's here. But do bear in mind that every time that I type Singularity, what I'm effectively typing is the equivalent to this long command here. And in the documentation, in the material, as I run through it, you'll see that I do provide reminders of that. So if it's not clear, then you should see it again further down. But also bear in mind you can use your terminal history as well. So somebody's saying that they have a problem with the screen display. Is anybody else having issues with the screen? No, looks okay for most people. Okay, so it might be just if you've got if there's a problem with it. I wonder maybe whether you, I don't know, you probably can't close the screen share, but you might need to. I don't know if you need to refresh your browser. Maybe you need to go out and come back in. But right, so there's a question. There's a question here about why we're running Singularity inside Docker. So basically, that's because if you don't have a Linux machine, there's not really a straightforward option. I will say there's a caveat to that, which there is a beta Mac desktop version of Singularity, but for the purpose of this, the way to look at it is that this, for people who are particularly running Windows, and in many cases also Mac, there's no other easy way to run Singularity. So that's why we're running it inside a Docker container, because the fact that you learned Docker yesterday puts you in a great position to be able to use that. Sorry, Andy, did you want to?
Yeah, I was just going to say, you know, as we talked about yesterday, one of the reasons for using Docker is to skip all the complicated install steps and fighting with that sort of stuff. And that's what we're using Docker for here, is installing Singularity on your local system, be it any sort of system, Linux, Mac, Windows, is painful, difficult, and fraught with troubles. So to get around that, we use the Docker image to get a copy of Singularity locally. The reason we can't use Singularity on ARCHER2, which is what we were doing this morning, in this afternoon, the bit we've been doing this afternoon, is to be able to build Singularity images, you need root privileges, you need escalated privileges on the system, and you don't have them on ARCHER2 because it's a shared system. As for yesterday when we were building Docker images, you know, you have to have a system where you have that ability to be a privileged user, which is your local machine. So what you're doing here is building Singularity image, which you can then take to the HPC system where you don't have the privileges, and then run them there, even though you built them here.
Yeah, thanks, Andy, for that. And there's also actually a great question in the chat there, which actually somebody has answered. But there's a question asking, when you call Singularity this way, i.e. through the Docker container, will it create a cache on the local machine, or will this cache disappear when it exits? And so what will happen is that the cache is created inside the container, and so when the container exits, it disappears. What you could do, although this is kind of getting beyond what we're doing here, is you could bind mount a directory from your local machine into the container to the relevant location in the container where it stores the cache, and that would mean that the cached content would be stored on your local machine. But ultimately, the Singularity version that we're running inside this container is completely unaware of your machine, the external machine. All it can see is if you've mounted a directory into it, it just knows it can write stuff into that directory, but it doesn't know that that directory is actually on the host machine, effectively. So yeah, so this just all happens in this kind of little sandbox of the Singularity container, and then once it exits, everything's gone. It's only that if you've bind mounted a directory, as we've done here, that the files can persist on the host machine. So that was a good question. So yeah, there's also a good point there highlighting that this actually is a great demonstration of why containers are useful. So it's actually a really nice kind of second part to the course, given that what we learned yesterday, and it does demonstrate the value of containers and the fact that we can actually run something easily on a range of different platforms that we can't easily run otherwise. So okay, I'll just close that poll. Right, so we're now at the point, hopefully, where people can run Singularity with the necessary privileges to build images. And we're now going to look at actually building how do we actually go about building a Singularity image. So I guess I possibly mentioned this earlier, but just to highlight that one of the really important parts of containers in general, but particularly useful with Singularity, is this idea of reproducibility. So you know, with a container, you've got basically a definition that defines the structure. We saw it yesterday with Docker files, and we're going to see it in a minute with Singularity's definition files. You've got some kind of information that defines very clearly the structure of the container and the way it's built, and that makes it highly reproducible. So basically you have your definition file. If you rerun it, you'll be able to create an environment exactly the same each time you run it. And so this is great for cases where, for example, you're doing some experiments and you've got a bunch of software that you're using, and you're using very specific versions of the different pieces of software. Maybe you've got a pipeline of doing some image processing or something like that, and you've got different versions of different tools, and so it's a great way to be able to kind of bundle all of the metadata about the different versions of everything in the context of scripts that build the container into one file, which you can then easily store into your version control system, as we saw yesterday as an example with Docker files. But it's also a great way to then be able to just reproduce an environment. And because Singularity is now increasingly, I think, widely available on HPC infrastructure, it's great for doing kind of HPC, doing processing for research data and so on. And so I think that's a really important aspect of this, and it's really, hopefully, gives a really good example of how, from a reproducibility perspective, these kind of containers are very powerful. So again, that's something which, if you'd like to discuss more, or you have questions about that, we can certainly look at that in the break. We'll be having a break probably in around about 10 minutes, maybe just a little bit less. But for now, I'll actually move straight on and look at the approaches to building images. So there are some different approaches to building images. There's a couple that I'm going to highlight here, and we're going to use the second one. The first one is building within a sandbox. Now, what we do in this case of a sandbox is we basically create, build our container build our image rather interactively. So we create a directory on our system, or we tell Singularity to create a directory on our system, which is our sandbox. And then we would go into that directory and we would start installing all the files and things that we need into there. And we can go and work through that by trial and error to get all the bits and pieces that we need in there. And when we finish doing all of that, we tell Singularity to bundle it as an image. So it takes that directory, that sandbox that we started to work in, and we've put all this stuff in there, and then it gives us an image at the end, which is our kind of complete image that we can then use. So that's one option. The other option is to use a definition file, which is effectively the same as what we saw with using a Docker file yesterday. And we're going to use that approach of working with the Singularity definition file. That link here, the building from a Singularity definition file link, gives you some more details about the different options. In fact, it looks like that might actually link to the sandbox rather than, does it give you the, that actually gives you the sandbox option. I'll update that link, but there's a whole bunch of information here on this building a container page that takes you through all the different types of containers and how to build them and so on. Okay, so the question here is why do you think we are looking at definition files rather than using sandboxes? Does anybody have ideas about that? So it's just something to think about for a minute. Why might we prefer to use a definition file than using a sandbox to build an image? And remember, the sandbox is this idea where you have a directory and you just kind of copy all the files in there and you install all the stuff into it that you need. And then when you've finished, you tell Singularity to create an image from it, and it will convert the sandbox into a fixed image. If you've got any thoughts on that, then do put them into the chat, and we can discuss that. I'll just give you a kind of a minute to think about that. So the answer to that is actually reasonably simple. Why might we want to use a definition file rather than the sandbox? Well, in this case, I just talked briefly about reproducibility. If you think about sort of trial and error approach you take to solving problems, if you want to create a container in a sandbox, you create your sandbox, you probably install some packages into it, you copy in some configuration files that you need, and then maybe you try to run it and it doesn't work, and you realize that maybe you've got the wrong version of a package, so you update the version of the package. Okay, that's fine. Then you try it again, and then something else doesn't work. So you need to change your configuration file. So you fix that. And this kind of trial and error approach, eventually you get to something that works, and you then create your image. Well, the problem that you have there is that there's no kind of provenance of where the configuration comes from. The steps that you've gone through to actually get that working configuration are effectively lost. And then if somebody else needs to create something the same, there's a bit of a challenge for them. If you just give them the image, that's fine. But if they need to create an image that's equivalent to that from scratch, then they might have a problem to actually reproduce that environment. Conversely, if we look at the idea of a definition file, that gives us a much nicer approach, because basically we have something which sets out very clearly all of the steps. And it may be that you have to go through a few iterations to get your definition file perfect, because maybe something didn't work the first time and you change it. But at the end of it, you've got something which expressly sets out the steps that have to be followed to give you a container image that is of the specification that you need. So that's basically explained here. So. And there's a point actually in the chat there about whether this is to do with not wanting to install things on your system. Of course, that's really important. If you've got if you're pulling down stuff from a remote platform or whatever, if you have it all set up in a definition file, then it just basically gets pulled down and bundled into the image, and it's a little bit more straightforward than doing it by kind of sitting there and manually putting everything in. But there's also a question about whether you can create or extract a Singularity definition file from a Singularity image. As far as I understand, or as far as I'm aware, no, because the Singularity definition file exists kind of outside from the image, and it's used to create the image, but it doesn't ever get embedded in the image, if that makes sense. So it's a recipe for creating the image, but it's not then something that is. There's of course no reason why you couldn't copy your Singularity definition file into your image as a way to kind of store the information about how that image was created, because it's just a file. So there's no reason why you can't put files into images. So that's something you could do. As far as I'm aware, it's not embedded in the metadata. But if somebody else knows otherwise, then do let me know. But I think that's the case. So we're now going to look at how we actually create a definition file and then use that to build an image. And hopefully we can just get through this before the break. So so a definition file, as I say, it's a text file. It's basically the same as what we saw with a Docker file. It's very much in line with this idea of configuration as code. It's the idea that you store the configuration as a file. That file can then be stored alongside your code. Apparently you can. Okay, I hadn't realized that, so that's great. So in fact, you can indeed get your definition file from the by using the Singularity inspect command. Thank you for that. That's great. So and there's also a question about whether people upload their definition files on Singularity Hub. Yes, so I believe there are different approaches here, but in fact and I think Singularity Hub is able to do this. You can actually upload your definition file and then have your container built within Singularity Hub, I believe. Certainly there are other platforms that will let you do that. So I've got some notes a bit later on. There's a remote builder service from Scilabs, who were one of the people, I guess they were sort of behind Singularity originally, who actually have a remote build service, and I've got a link to that a bit later on. So you can actually upload your definition file, and then the container, the image rather, is built from that, and you can then pull that image and create containers from it. But yes, there's a lot of flexibility with these kind of things. So now we're going to look at a simple definition file. So this is a really basic definition file, and I'll just quickly walk you through that, and then we can look at using that to build an image, and hopefully we can get to the end of that, and then we'll take a break. So this is our very simple example image file. Sorry, definition file. So what do we have here? I'll kind of walk through the sections. So there are a number of sections in the definition file that are optional. These sections starting with a %sign. There's a number of different sections that you can highlight. There's some more detail in a moment, but for now we're using just two of these sections, the post and the run script. So you can find actually on there's a really good reference on the website. There's a link there to it. But as I say, I've got a little bit more detail further down, as we'll see in a minute. But let's just step through these sections of the file. We'll just have a look at what this is actually doing. So we've got here the start, which says bootstrap Docker from Ubuntu 2004. So what does that say? That basically says that we're using we're bootstrapping our image. So we're going to create the image from a base image. And in this case, the base image that we're using is coming from Docker. And the image name is Ubuntu with the tag 2004. So we're going to use basically the Ubuntu 2004 Docker image as the base for our Singularity image. So there's actually so apparently the Singularity, the definition files are not visible on Singularity Hub. I'm fairly sure you could upload them, but and have it to create an image, but maybe the files are not available. But anyway, that's something I can investigate afterwards. So we've got this start which says we're going to create our image from. So our Singularity image is going to be created from a Docker image, which is Ubuntu 2004. That's what the lines at the top are highlighting. There's different bootstrap options. Again, within the definition file section, you can see all the different kind of platforms that you can bootstrap from. Then we have this post section. So the post section is run within the container context, effectively. So we start off with this container, we pull this Docker container, and then we run some commands inside the Docker container, effectively. To install things that we need, or to set files up that we need, or do configuration or whatever. So that's what happens in the post section. So what this is actually saying here is it's going to use apt, or in this case using apt-get, the packaging tool in Ubuntu, and it says first it does an update. So I don't know if you're familiar with Ubuntu, this will probably seem fairly familiar, but if you're not, I'll just go through a little bit about that. So basically what this is doing is it's updating its package lists. So this is all the lists in Ubuntu of the different packages that are available. So it goes out to a remote server and it says, tell me all the latest packaging information. So that's what the update does. And generally we do that before we do an install, particularly because we've got an image that we've just pulled, so that may not be that up to date, depending on how it was created. And then we say install the package Python 3. So what that will do is it will install the Python 3 package along with any dependencies that are required for that image. So that's basically just installing Python 3 within our image. And then we have the run script, and we put in here what we want to run, which in this case we're going to run Python 3 that we've installed, and we're going to just literally tell it to run this piece of code which just prints out a message. So it's very, very simple. But what you'll notice that run script section, what that's specifying is the thing which we saw when we did the inspect -r. So when we did Singularity inspect -r earlier on, and we saw the script that was run, this is basically that script. So in this case, it's just one command, but that's the section where we put in the script to be run. So at this point, you should be able to create a definition file using the example that's up here. So what we can do is actually just copy and paste that. Should work fine. So you should be able to copy and paste this section of the file. And I'm now going to, so I'll just clear that, and I'm going to create a file. So I'm just going to use vi, but equally you could just cat the file to. So if we just cat to the file, it might be easier to do that. So we're going to create a file. It's called. It doesn't really matter what you call it, but I'm going to call it mytestimage.def. So say cat the contents into that file. I press enter, then I can paste in what I want to go into the file. So go back up here and take this again because I pasted something else. Let's take that, paste the contents into the file, add a new line, and then we do Control-D to close the file. So you could equally use Nano or VI or any other editor that you're familiar with to do that. So that was just a sort of quick way to do it for the purpose of this. And if we now have a look, so in fact we cat the file now, we should see that it's there. There's the file, and that's going to be our definition file that we're going to use to create our image. So just scroll back to here so I'm at the right point. So what I should now be able to do is run Singularity build, and then tell it the name of the resulting image file that I want to create, and the definition file to use to create that. So if we recall from before, I've got my alias set up for Singularity. So if I type Singularity, it'll still be available, which it is. But if you haven't set up an alias, or you're on a platform where that's not straightforward to do, you've got the command here below to show you what we're running. It's basically the equivalent of running that. So I can say Singularity build. I'm going to say, so in fact, what I have to do here is I have to specify, it's slightly complicated with the path names, because in fact, these are the path names that are used inside the Docker container. So even though I'm not in a directory called home Singularity here, because I'm actually bind mounting into the directory home Singularity, when I'm in the container, when I'm in the Docker container, this directory, which happens to be called Singularity data here, is called /home/Singularity. So that's why the directory names don't match. It's a little bit confusing. But let's just say that. So build home Singularity. So the name of the image files I want to create. So we'll call it my test image. Let's try and test image.cif. So that's the image file. And the thing that I'm going to build from, which is my test, I call it, I want to remember, did I call it my test image.def? I think I did. Test image.def. Right, so let's run that, see what happens. So something's happening, it's starting the build. So this is happening now inside the Docker container. So within the Docker container that we had, it's running Singularity within the Docker container. It says, so that's interesting. So I think this could be a result of me not using ---- privilege, but I did try it before without successfully, but that might actually be what's going on here. So let me just update my alias. Go back to here and put in ---- privilege. So that's a good example, if it is the case, as to why you need that. Oops, that was the wrong one that I updated there, because I forgot to put the quotes. Let's just fix that. Okay, let's clear that to make it cleaner again, and let's run the build command again. So it's pulling the Docker container again. It's getting all the blobs. It says it's going to unpack everything. Right, this looks more promising. So what we can now see is this is the apt-get update that's running. It's all flying up the screen very quickly, but what it's then doing is installing a bunch of packages to install Python 3. And it's adding the run script, which is what was in our %run script section. And there we go, it's finished. And we should now have an image file in this local directory. And as you can see, the build was completed as home Singularity my test image, because that was the directory, the path to the file inside the Docker container. But the Docker container is now shut down, but because we had bind mounted this directory, we should see that that file is actually here now locally. So it does get a little bit confusing because there's multiple levels. So we're obviously here on the host machine, then we did the stuff inside the Docker container where the directory names were a little bit different. And then in turn, we use Singularity within the Docker container to actually do the build. So there's a few levels of sort of indirection there. But hopefully you've been able to run that command and get an image out. And what I should also be able to do now as a test is I should be able to run that. So if I say Singularity Run, see what happens. What doesn't it? Oh, hang on, that was my mistake. I forgot to put the path. I think I need to put the path. Yes, excellent. Right. So we've now built a Singularity image, and we've used the version of Singularity that's inside the Docker container to run it, and we can see that it's there and it's run. So basically, this is the output that we got. It's all been truncated because there was a lot of output, as you saw, but it went through. It pulled the Docker image, the base Docker image. Then it ran the update, apt-get update, which basically went off to the Ubuntu package repositories and updated all of its package metadata that it can pull from there. Then that finished, and then it said, what do I need to do now? I need to run apt-get install -y Python 3. The -y, I should say, is just to stop it from asking. Normally it would ask a question saying, are you sure you want to install? The -y just suppresses that question, so it just means we can do it in an unattended manner. So there's no interactivity. We then saw a load of output that went flying up the screen here, where it set up all these different packages. We can see all the different packages that it was setting up. And at the end of that, it then added the run script, which means it put in the thing which it knows what to run when you run Singularity Run. And it's created the CIF file, it's bundled up the CIF file, and we got the file out. And then we showed that we were able to run it. There's a few additional notes here. I think in view of time, we should probably take a break, and then I'll kind of finish off with that, and then I'll go on to looking at doing MPI stuff. Welcome back, everybody, and we will get going again with the next part of the building images material. So hopefully my screen is now visible to you again. So just before the break, we looked at this material building a kind of first simple image. There's some notes here about the permissions of the created image file. You may find, depending on how your system is configured, that the image file that you get ends up as owned by root. So it's owned by the administrator if you had to run things with root. But there's just a note there to say that you should be able to read that, so you can always copy it. You can copy the file, and you will then own the copied version, and you can then modify that file or move it places or do whatever you want to do with it. So that's a kind of workaround if you find that that's the case. Right, so we looked at testing the image, and I think most people have managed to get it working. I know there are some people who are still having some problems there, so hopefully if you are having a problem, somebody is assisting you with that. But basically, just to expand the little solution section there, we did, as I say, look at this prior to the break, but that's basically where we got to, and you should be able to see the output. There's just a note here about using Singularity Run within the Docker container. So really, this is not this is definitely not the recommended way to be running images. It's fine as a test for the purpose of this material, but obviously you should be looking at the material, looking at running this on a platform where you have Singularity actually installed. So the material here is just showing you some sort of details about that and just giving you a little bit of background information. But do take a look at that if you're kind of curious to find out more about why that's not a good idea. You'll find some more information. There's some information there, and then as we go forward. So we've now got this image. We've run it locally. And as I've just pointed out, there's probably not the most ideal way to run it. What we really want to do is run it on a platform where Singularity is actually installed properly. And for that, we're going to run it on the HPC platform. So what I've done here is given you an example. So here I have this image. I do an ls. You can see that the image file is here. It's on my local machine. But actually, what I want to do is probably put it on a platform where Singularity is installed. In this case, it's an HPC platform. And so we have the ARCHER2 platform that we have been given access to as part of the course. And so this gives you an example of how you might securely copy that file to another platform. And what I will do is just show you. So some of you will have been able to do that, I guess, already. And if you haven't, you should be able to do it using the SCP command. If you're running on Windows, I think now on Windows 10 you probably do have SCP installed by default. I know SSH is normally available. So yes, so in fact you should be able to do something along the lines of this command. So the -i tells SCP which key rather to use, which SSH key to use when accessing the remote platform. So that will be your key that you set up for your access to the remote system. The file we want to copy is the image file, and then the place we want to copy it to, which will be the target host name, and then the colon at the end. Normally after the colon you would put a path where you want to copy the file to, but in fact if you don't put anything after it, just copies it to your home directory, which should be fine for testing this. So if you've been able to do that, that's great, and you should find that the file has been copied. I'm going to switch across here to my other terminal window on ARCHER2. In fact, that's actually appears to have died because I think I haven't been there for a while, so I'll just wait for it to time out and then will open up another one there. In fact, what I'll do is just open a new window. So let's just do that. In fact, it's timed out now, so I can do that straight away there. I'll just use the same window. It's probably easier. So I've got something set up in my configuration, so I can actually just type that, and that gets me to the point where I can then type in my password, and then I'll be prompted for my key password if I type my password correctly. And then I should be able to type my key password, and I'm now into the system. So the reason I only just had to type the machine name was because I've got an entry in my SSH configuration file which tells it which key to use and what the host name is that it's connecting to. So it just makes things a little bit easier. But if you're interested, I'm sure one of the helpers can provide you some information about that. Okay, so now I'm on the ARCHER2 platform, and I can go into my Singularity directory. There is my test image that I prepared earlier, and here it should simply be a case of running Singularity Run, and then the name of the image, and there it goes. So we get that warning as usual about the bind mount, but the output is there, so that's running successfully. So hopefully many of you have got to that point and you've been able to run the image at least to see that it was possible to build and run an image. I have got some information here about the more advanced definition file content. I won't go into that really in any detail other than just to highlight that these are the different things that exist, the different sections that exist. And we'll see some of those in a minute when we look at a slightly more advanced example. The other thing just to highlight here is some other features. So there are a number of other features. We're obviously doing a kind of basic introduction at the moment, just to give you an idea of the core kind of functionality with building and running images. I did mention earlier this remote builder capabilities. So if we just look at that briefly, you'll see that on the Scilabs cloud there's an option to build a container, so you can sign in, and what you can then do is you can actually, I believe you can actually just paste a definition file onto the site, but alternatively you can actually do it from the command line. So there is actually an option in the Singularity command. If you put the - remote option, you can actually get it to build from your definition file remotely, and then you get your image back, which is great. So those are some different options for building images, particularly that avoids you having to go through the business of building stuff locally if you don't have root access. I believe that you can do that without root access, but somebody else can perhaps confirm to me if that's correct. But I think that's one of the benefits of that option. The other thing that I highlighted there in the additional features is this point about assigning containers. So if you want to share images, then obviously there's potentially problems with files either getting corrupted or somebody maliciously doing something to a file to try and change its content or whatever. And so if you sign containers, then that gives you a way of verifying that the container is unchanged, and also verifying that the person who sent it to you, or the person that originally signed it, is the person who they say they are. So there's a bunch of information on that. Basically, it's using digital signatures, and there's a bunch of information on the signing and verifying containers page. So that's something that you might want to think about if you're going to get more into using this and sharing containers and so on. So in this section, we've looked at how definition files work and how to build a basic definition file, and we've also looked at how we can run Singularity in a Docker container to be able to do tasks which we would normally need root access to do on a platform where Singularity is installed. So this gives us quite a bit of flexibility with how we manage the process of working with Singularity, and we've also looked at how we can actually build on existing images from either Docker Hub, Singularity Hub, or, as was pointed out earlier, a range of other different places. There's various details of that in the documentation. So I hope that's given you a kind of a general overview of that. What we're going to do now in the last kind of 25 minutes is come and look at a more advanced task. So we're going to look at running MPI parallel jobs. This is something which, I mean, time-wise, we're quite limited. I'm happy to go on beyond 4 if people want to, but I do appreciate that we advertised that we were running till 4, so that maybe people need to go. So there will be a follow-up session at the start of January where we will have the opportunity to, I don't know if actually the data that has been circulated, but I think it probably has it, Andy? I don't know whether...
I don't know if it's been sent out to the attendees or not yet. It might go out in the email that goes out after, just straight
Okay, so maybe we'll go out in the follow-up email. But there will be a kind of follow-up, which is a sort of optional follow-up session at the start of January for anybody that does want to join then, and we can certainly go into some of this material in more detail then if people are interested. But I will go through this probably relatively quickly now to show you how it works. And if you want to follow along and you're kind of keen to get through it, then certainly there will be people, if you are able to stay beyond 4, there'll be people who will be happy to sit and work through that with you and to help with any issues. But I will kind of go through it and see how things go now. So what we're talking about here is MPI, which is Message Passing Interface, and this is a widely used parallel programming standard which is used for sending messages between processes on different nodes. Well, it doesn't have to be on different nodes, but it's generally designed for sending messages between processes running on different nodes on cluster platforms. So it's something which, if you are using scientific codes, you may have encountered. A lot of large-scale scientific codes are MPI codes. There are different approaches for parallelizing codes, so you may also have seen codes which are OpenMP, which focus on parallelization within a multi-core node or running multiple processes within a single node, and you can have hybrid codes which use both. But here we're focusing particularly on MPI, and effectively we've got a code which we're going to show you an example of a code which has multiple processes that talk to each other using MPI to send messages back and forth between the processes. And so this means that if you've got a large complex code, you can run lots of processes on lots of physical nodes on a cluster, and they can all do the relevant bits of the computation, and they can all communicate with each other via these MPI messages using the MPI library. The MPI with Singularity containers starts to get a little bit more complicated than just normal MPI. So within Singularity containers, as I say, MPI is a little bit more complicated than just working with MPI locally, and I'm hoping that I'll be able to give you a little bit of a flavour for kind of how it works and what the complexities are there. There are kind of 2 core open source. I mean, there are many different MPI implementations, but there are 2 core kind of open source implementations that you may have encountered if you're working with MPI. One of them is OpenMPI, and the other is MPitch, which I'll put a link to there. And the benefit of, well, so these are as I say, they're widely used. The benefit of MPitch is that it has binary compatibility. So this is the ABI compatibility. It's got binary compatibility between several other MPI implementations. So often on large-scale clusters, you might find that there's a sort of commercial implementation of MPI or something that's been installed on there that's been specially set up to be optimized for that platform, and that many such implementations are compatible with MPitch, which, as I say, is open source. So there's a compatibility between the different versions, and we'll look at how that's kind of really useful in the context of Singularity in a moment. So the other thing that's quite important to highlight here is that generally when you work on an HPC platform, you will build your code on that platform. So you've got some code, you've tested it maybe locally on your laptop or on a multi-core server or something you have locally, you know everything kind of seems to work, but then you move it off onto your HPC platform and you'll generally build it again from source against the libraries that are on that platform, in order for it to link up with the relevant libraries and make best use of the infrastructure that's there. So that can be a challenging process sometimes, building these codes on a remote platform that you're not familiar with. And so one of the nice things with Singularity is that we can actually build our codes in a Singularity image off the HPC platform, a bit like we've done with the test image, and then we can move that image onto the HPC platform and run it there. And there are pros and cons of this approach. One of the major potential issues with doing that is that if you have very specialist hardware, so for example you have very high performance networking interconnects between your nodes or something like that, it can be challenging to get your codes to actually make use of those if they're not built directly on the platform. But there are some tweaks and some approaches that we can use with the way we build Singularity to support that and to address that issue and improve the performance of our codes such that we shouldn't lose too much from running locally on the platform or building locally on the platform. And we'll just look briefly at that as we go through this part of the material. So there's a little bit more description there, and we do highlight some different models of how this works. And what we're going to look at here is that when you run your Singularity container on the remote HPC platform, we will have MPI built in our container, because we have to, because our code in the container needs to link against the MPI libraries. So we've got this we build an image, as you'll see in a moment. We have MPI in the image, and we have our code that uses MPI, and the two of them, our code that uses MPI links against the MPI libraries inside the container. But then when we move that image onto our HPC platform, we want to use the implementation of MPI that's on the HPC platform. And what we'll show you is how actually we use what's classed as this hybrid model, where we use the kind of the core MPI daemon and whatever that runs on the HPC platform as the kind of basis to manage the communication between the nodes, but then our code itself will run inside our container and use the libraries in the container that we've given it. So there's a kind of communication between the two layers. And that's one of the nice things about this approach of using containers, and it gives us a lot of flexibility. And it does also mean that we have this opportunity to build somewhere else and then to move the container onto a different platform. So what we're using here as an example, we've got it's actually a very simple example, but there's these OSU micro benchmarks, which is just a small benchmarking suite for benchmarking MPI functions. And what we've done is set up as an example a Singularity definition file that will build the micro benchmarks, which are an MPI code, so they need MPI. So we also build MPI within our container, within our image rather, and we basically build that, and we produce this Singularity image that's got TI code in it with MPI, and then we're going to show how to move that onto the ARCHER2 platform and run it on there. So what I'll do is I will start the build of this particular, so you can actually download the definition file. There's a link here where you can download it. And if I actually download that file, so what I should be able to do is just copy it, and then what I'll do is go back to my local platform here. I will use wget because that's a quick way to grab it. So in fact, I already had it there by the looks of things because it's named it with a number 1 at the end. And I'm now going to use that as my definition file to build a container. So to build an image rather. Sorry, I'm getting confused with my own terminology. So we'll go Singularity, and we'll say, and I think we've probably still got the alias in place in that terminal. Yes, so we're going to go Singularity build. We're going to give it the definition file. I'll use the file that I've just downloaded, which is this file here. So it's the OSU benchmarks, and I'm going to use the number 1. And in fact, I need to give it the image file name. So we have to remember our home Singularity. So home Singularity. So OSU benchmarks demo.cif, and the file that we're going to use to create that is home Singularity OSU benchmarks. Right. So the other thing that I have done here, which I should have highlighted before, and you'll see in the instructions, is that I've actually already downloaded the 2 files for the source code for the things that I'm going to build in my image. So I've been to the website. There's links in the document here. So if you're following this along, you'll need to download first from the OSU micro benchmarks page the tar file for those for that code, and then you'll also need to download from the mpitch page the mpitch tar file. The reason I've started this off in a bit of a hurry is because it's going to take a few minutes to build. So I'm kind of keen to get that going. So what that's done is now it's actually, well, I'll walk through the file here to show you what's actually happening. But as before, we are starting off from the Ubuntu 2004 container. So it's from Docker Ubuntu 2004 container. Here we've got a new section, the files section, which we didn't see before. What I'll also do, sorry, is I'll just put this down to the bottom so you can see when it's still running. Not very exciting, the output, but it is. We can see that it is actually still doing something. So here we're using the files section. What this is doing is actually copying some files into the image that's being created. So what it's saying is take this file that's on my system because I downloaded it and stored it there, and put it into the /root directory in my image that I'm creating. And then it says, take the mpitch 3.3.2 tar.gz file and put that into the root directory in my image file. And the reason we need that is because we're then going to use those as part of the build to actually build the software. Here we've got the environment section, which I think we also didn't see before. That sets an environment variable within the container. So within the image, but then within the container that's being run to build the image. So basically, when we're running commands in the post section, that environment variable will be available to us if we want to use it. So we then have the post section, which we had previously, which is where we run a bunch of commands within the context of this image that we're going to create. So what you can see happening in the background with all that stuff scrolling up on the terminal is basically this process that's running. So what's it done? It's basically created, it's done the same as we did before. It's done an apt-get update. It's then installed some core packages, so Build Essential, libfabric, libivverbs, and G4tran. Build Essential gives us a bunch of essential build tools, compilers, and so on. These two packages are related to the support that we're building into MPI. And then G4tran is a Fortran compiler because we want to be able to, some of the code that we're compiling has Fortran elements to it, so we need a Fortran compiler for that. So what this then does is it goes off to the root directory, and if you recall up here in the files section, we put these files into the root directory. So it goes into the root directory and it unzips the MPI, the tar file for MPI, and it prints a message telling us that it's configuring and building mpitch. We probably flew up the screen so quickly we wouldn't have actually seen it. But it then calls the configure script, which will run the configuration. There's a few options that are set there. So it says configure the build of MPI. So if you're familiar with building anything from source, this may seem fairly familiar to you, running configure and then make. But if you're not, this might seem a little bit strange. But this is a kind of standard process for a lot of code that's being built from source. So we run the configuration. We then say run make -J2. What I should probably have done is increase the number 2. That means it runs 2 build processes. If I'd put a larger number there, I could have sped it up a little bit. But obviously that depends how many cores there are on your machine. So I think I put 2 in there to be fairly conservative with the resources that it's going to use. But once that's eventually done, it then has, we then calls make install, which will install the mpitch code into the image. And then we do the same again for the benchmarks code. And the benchmarks code needs to use the MPI that we've built here. So that's why we have to do the MPI first. So we build the MPI, we install it, and then the micro benchmarks will build, and they will use the MPI that we've actually just built to build those codes, because it's an MPI code, and therefore it needs to use the MPI compilers. And we then do the same. We do a make and we do a make install. Then we have our run script. So this is what runs, as we've seen in previous examples, when we actually come to run the code. Sorry, when we run the image, we create a container from that. So when we say Singularity Run and then our image name, it will run this script. So what it does is it outputs some, it echoes some text to the console, so it tells us what it's about to run. And then it goes and actually runs what we've told it to run. What we're doing here is we're actually providing a path to a particular location. So this is the location where all of the OSU benchmark tools, there's a whole bunch of little executables that get installed. And this is the location where they'll be installed. And what we will provide is the name of the thing we want. So it basically saves us having to write this whole path all the time. It will just add on to this path the name of the benchmark test that we want to run. So that's what it's going to do. It's going to run exec, and then this $* basically takes the parameters off the command line. When we say Singularity Run, it will take the parameters off the end of the command line and put them onto the end of that string there to run that command. So that's explained in a little bit of detail. As I say, I do appreciate that I'm going through this quite quickly. So if you do have questions, then happy to answer those. Either at the end or probably easier at 4 o'clock, because we're just approaching 4 o'clock now. But basically that's the process of building the code, and what we will then do is actually move that onto onto ARCHER2 and be able to run it. What I'll do is, because I've got a version of this actually on ARCHER2, while that's churning away running, I will move on to there and show you how that works. So that's probably the easiest option. And I apologize if you can hear background noise. That's my laptop getting rather hot going through the building process. So hopefully it's not too noisy for you, but if you can hear a lot of background noise, do let me know. Okay, so I'm now what I'm going to do is I'm going to go onto my work directory in. So we should all have. So you should have within ARCHER2. So I'm on the ARCHER2 terminal now. A directory in /home, and then the project name you can see here, which appears twice, and then your username. And you should have one in /work. And I'm working in the work directory to run my image. So if I have a look in here, I've got a job script. So this is a job script. There's actually one provided in the examples here. There's a template job script that you can download. So I think it's in this section here. So here's the link for the template script. So if you look at that, in fact, it won't display it there, but I'll show you it on here. Basically, there's some little placeholders that you can replace with your the account code, which is the code here. And then your username. I don't think, maybe you don't need to put your username in actually, but there's a bunch of things that you can edit in there, and I'll show you. This is what it looks like when that's been done. So this is my completed job script, and this will, if you do download the template and have a look at it, it will look very, very similar to this, but you'll see I've filled in some of the things. So I've given my job a name. I have said how long it's going to run for. It's a very tiny example, so I've just said 10 minutes. Actually going to run for a few seconds. It's going to use 2 nodes. So of course, normally we'd be running much, much bigger jobs than this, but here, just for a simple example, it's going to run 2 nodes, and it's going to run 1 task on each node. We set up our account code. We've set up these are the kind of standard parameters for the quality of service and so on. We're setting up a couple of a module that needs to be loaded, set up the environment, and there's a few other parameters. Really importantly is this parameter here, which is setting the library path within our Singularity container. So what this is doing is setting up the paths so that a bunch of directories are on the library path, so that when we run our executable, it will basically it will look for the libraries that it needs in these locations. And these are the locations that are storing the libraries that will ensure that MPI will work on this platform based on the build that we have within our container. So that's a really critical part of the file, and that's very specific to this platform. So this is really demonstrating that our container is kind of generic in a sense, because we built it with MPI built in, but in order to actually run on this platform, we need to ensure that it links against the right libraries, and we point it at those libraries by adding in this this particular thing. So in the template that you can download, you will find that should all be in there already for you. Similarly, there's a few options that we provide to the Singularity command when we run it. And again, these are kind of specific to this platform that we're running on, and different platforms probably have different sets of options. But those are also provided in the template. And what we then do is we want to run this. So we use srun to launch the parallel job. We use this parameter, the CPU bind cause, the standard parameter that we put on, and we then tell it to run Singularity. So we say Singularity Run. So this bit should look fairly familiar to you, the Singularity Run and then the image name. And then at the end of that is the command that we want to run. And as you saw just before, at the end of our definition file, we basically append that to the long path that was in the definition file. And then we provide these options that are up here. So we're just basically adding those into the command line rather than typing it all in the command line. It's been done as a variable. And basically, we should be able to submit that script and have it go off and run a batch job. So it will go off onto the queue, and it will run. And what I will do is I will just see if my thing is built. No, it's still building. So what I'll do is I'll just drop back to here, and I believe that I've got here. Let's just have a look. I can probably just take it from my home directory. There. Have I got the CIF file? Yes, I have. But I'll take it from here. So that's what I would get if I've uploaded it. So what I was going to do was basically, when this build finishes, take the file, SCP it as we saw with the previous example onto the ARCHER2 platform, and then it would end up in my home directory. And basically, I've just copied from there a version that I had there. So what we've got now is we've got our CIF file here, which is what we will get when this build on this window finishes. We've got our Slurm submission file, and what we should be able to do now is say sbatch osu latency.slurm, and in fact, I'd better double check if I've got my paths correct there. So I'm just going to look again at that before we run it. Let me just double check if I've got that in the right, what I'm running is in the right place. I guess it's probably okay because I am in the current directory, but maybe just to be sure, I will actually put the full path in the front of that. So give it the full path to be sure. So what I'm going to do, oops, edit my script, and just on the front of the image so that we know that it's picking it up in the right place, we'll add the path onto it. And now I should be able to say sbatch osu latency slurm. So submitted a batch job, it gives us the number. I can check whether it's in the queue by running that, and we can see that it is actually there. We run that again, we see that it's actually sitting in the queue at the moment. So I guess that will take a moment to get going, but it should start any minute now. So there's a question about the Slurm template. So it's actually in the material here, in the web page material. There's a link in the section which says undertake a parallel run of the OSU latency benchmark on the cluster. There's a little link down here. Sorry, I should probably make it a little bit more prominent, but in that sentence there, the template script is actually a link, and you should be able to pull the file from there. So let's just have another look how we're doing here. It's still sitting in the queue. So I'm guessing that will start off any moment. What I could also possibly do is run it on a short quality of service, which might make it run quicker. Yeah, so somebody's actually put a message into the chat there saying that we can actually use watch to look at the queue. So that's true, yes, we could update the queue using watch. I guess I probably should do that, but I'm hoping, in fact, I don't need to do that now because it's finished. So let's have a look what happened. So if I just run like this, we can see that most recently the output is there. And if we look at the output from the file, we can see that it has actually run, which is great. So there's a bunch of stuff here that's appeared at the start, just telling us various bits that are being loaded. This was our printing out. What this is actually supposed to do is print out the rank number, but I think for various reasons we decided we can see why it wasn't doing it, but it doesn't print the rank number with this particular run. But what it's then done is it started off two processes of this latency test for the MPI gather function, and it is then basically passing blocks of data of different sizes between the two processes and doing some timing, doing some benchmarks. So what we can see here is that when the data size is very small, basically it all takes the same amount of time because it's probably so small. It's when you talk about very small sizes, it's very inefficient. So it's taking about the same time, and then slowly as the size starts to increase, we see the time going up a little bit, but we're still talking about very, very small amounts of time. So I guess that's 1 megabyte worth of data. So we're looking at sort of a few hundred something microseconds there. So that's, yeah. So that just gives you an idea of the fact that we actually can move something that we've built locally onto a remote MPI platform and then run it there. I appreciate that last bit. I've had to go through very quickly, but
one thing I should just add, Jeremy, is I compiled the native version without using the container and compare the performance, and it's almost exactly the same. So
oh wow, okay, right. So that's good.
You're getting exactly the same performance from whether you run in a container or whether you compile on the platform itself. So,
right. Okay. Fantastic. Thank you for that. Yes, that's something I was hoping that we'd have time to look at, but unfortunately haven't. But yes, so that's great. So and in fact what I did previously was not on this particular platform, but on another platform. I tested it with MPI, with a bundled version of MPI in the operating system, in the Ubuntu operating system. I think it was the packaged version, and actually found the performance was much slower. So that demonstrated that because that wasn't built with the right MPI device configuration, that we were taking advantage of the best performance available on the system. But it's great to see that by linking into by putting the various libraries of the local system and ensuring that we can kind of link against them through our container, that we can actually get very, very good performance, basically the same as running on the system by the sound of things. So, as I say, we've kind of reached the end of our kind of our timetable time. But I hope that's given you an idea, and I was very keen to get to this point, so at least you could see kind of what the process looks like and what it looks like at the end. And of course, if you want to continue now in the next sort of 30 minutes or more, I'm happy to stay around and answer questions and provide any assistance with that. But at the same time, for those of you that need to leave, that's fine. If you want to come back and have a look at this, the material is of course available online, and you'll be able to see. Well, you've been able to see what it should look like. So hopefully you'll be able to get to the point of running that yourself and being able to get that to work. And I think people probably have access to the platform, do they, Andy, for a little bit longer after the course finishes?
The idea is that you'll get to keep your ARCHER2 account until after the session on the 7th of January.
Fantastic. Okay.
So you can continue to use them and play around on the system and try Singularity on the system. The other thing I'd say is, if you have any questions or you want any more help, then please feel free to get in touch. And I think on the course website, it's got the help desk email for the ARCHER2 help desk. If you send a message in there saying I was on the containers course and I've got this extra question, then we can get back to you. That'll come to the right place and we can talk to you. Otherwise, if you think of questions and you don't really want to mail in, then if you want to come to the session on the 7th at 2 o'clock in the afternoon UK time, and we can discuss your questions there and do stuff. And if you want to have a look at the MPI stuff in more detail, we can take some more time to go through it and show it here.
Yes, absolutely. There'll be time, obviously, then. So, one option is if you want to look at this and you want to try and work through the material and you've got questions that you want to ask us at the session on the 7th, then that's absolutely fine. But as Andy said, do feel free to contact the help desk. Obviously very happy to try and help with that. So I guess all that's left for me to say now before we kind of officially finish is just to thank obviously Andy as well for yesterday's session, and to thank all the helpers very much for their help with answering all the questions and whatever. I think we really couldn't do it without all of the helpers volunteering to help out, and also thank you to all of you who've attended. And it's great to have a number of people on the course, and I hope that you found it useful. I hope you found it interesting, and I hope it's given you really nice demonstration of working with containers, and that you feel you've kind of got started with the process, and that you can kind of move forward with that if you've got use cases that you want to use containers for in the future. That this will be helpful as a kind of starting point for that.
Sure.
So yeah, thank you all very much. Andy, sorry, you wanted to say?
So we'll send out a request for a bit of feedback on the course straight afterwards. That'll come from Claire, who's the training coordinator for ARCHER2.
So yeah, thank you very much indeed. We'll finish the main session now. I'm sorry we've gone slightly over the 4 o'clock.